To test or not to test? That's a good question. So why do electricians, they test everything, test and test again? The amount of testing that we do as an electrician is crazy. But to be fair, it's needed. Electricity can kill, and we don't want to use our £5 million insurance cover even though we've got it. Toolbox talks for electricians, helping electricians reduce stress, gain back time and earn more money. Hey there, Ben Poulter, your host, back once again, and today's podcast is about testing. Working as an electrician, there's not many days that go by without doing some form of testing. But do you ever skip that part? And do you think, it'll be okay, I'm good at my job, I haven't had a fire yet? In this podcast, I'm going to tell you the repercussions of skipping the testing part, along with the explanation of why electricians test so much. But best of all, how testing can make you as much money as it saves you. Now, testing for an electrician is normally the boring part. Installing 20 downlights in a kitchen and completely transforming the look of that room is a lot more satisfying than getting a low ohms reading on your meter. But when you turn them lights on, that's the functional testing. That's also another test, but that's all making sure that it works. However, just because something works doesn't necessarily mean that it's safe and it'll work for long. So when installing a circuit anywhere or addition to any circuit, the testing is what confirms that it's done to a high standard and it will last. Firstly, with any job you do, make sure you take a loop reading, known as earth loop impedance test. This will give you a reading in ohms, testing the circuit to make sure the whole loop of the circuit is in working order before you start work. Because the last thing you want is to be tested at the end of the job to find that you can't get a good loop reading and it won't pass your tests. The fault was already there before you even arrived. This has happened to me before, where the earth was in the fuse board but it just wasn't connected. I haven't got a clue why. Maybe the previous electrician had left it out for testing, but it must have been like that for a while, and probably the reason why the previous electrician didn't get called back. So assuming you have a good ZE reading, and that's obviously the term used for fault loop impedance tests, that's when you get cracking to start work. But if that reading it is too high, I would spend maybe 5 minutes checking the common mistakes like no earth in the board, or let the customer know that there's a fault and it will need fixing and it may incur extra costs. And then while you're plugged in for your loop impedance test, if the current circuit is protected by an RCD, flip your tester onto the RCD and give that a test too. One reason for that is to make sure that the RCD isn't faulty before you start, and two, if you need that circuit off, then that's the best way to knock that circuit off on the right RCD or RCBO. And then go to the fuse board and get your little lock off kit and lock that circuit off so it's safe to work on. So then let's say that you've installed your new lighting circuit and it's say 20 lights in a kitchen, 20 downlights in a kitchen. The first test you do is insulation resistance, also known as mega in the circuit. And if the nominal voltage is around 240 volts, then you test it at double the nominated voltage, which is 500 volts. And at this point, you don't want to have any of the lights connected. You're only testing the wiring. Plus, testing at 500 volts could damage the new light fittings you're putting in. And the insulation resistance will make sure that the wiring you've put in, that it isn't damaged, or any other trades that haven't gone through any cables. And I'm not going to name any of the plasterers here either. So after installing all the lights and completing all of the terminations, that's time for the continuity test and testing live to neutral, live to earth and neutral to earth. This will all be tested with a circuit not connected into the fuse board. So if you find your end of line on that radial circuit, if it's a lighting circuit or if it is some sort of radial circuit, obviously you do it differently with a ring, but if you find your end of line and connect the cables together, and I use Wagos for this, which are perfect for it, and then test that ohms reading. It will give you a reading, and the on-site guide has a table that tells you the acceptable ohms reading on the cable sizes and the lengths. But over time you'll get familiar with this table and you'll get to know what's acceptable and what's not. Brilliant! your wiring is spot on. Of course it is. You're an electrician. We don't make mistakes. And it's time for the best test of them all. Turning it all on, selecting the correct fuse for the cable and getting to see all your hard work in action. The functional test. Now, if you're a cowboy, you would pack your tools away and you'd get out of there. Who'd ever know that you didn't even finish the testing? But if you've gone that far, you might as well complete a couple more tests, obviously for the certificate as well. And now you need to earth fault loop test it again. Also, we're testing that the RCD works, because you'll need them readings for your paperwork anyway. But let's just say you're one of those guys that, I can't be arsed with testing. And I don't care how good you are at your job, it only takes one mistake for everything to go completely wrong. It was just the other day that I second fixed a whole house with over 20 sockets. All the results tested spot on. Then I plugged my tester into each socket just to make sure that they had continuity and alive, neutral and earth were all there. And there was one socket that was wrong. And I remember which socket it was as well. It was when I had a phone call, because I was sitting down in that area, got a phone call, it took my mind off the job, and I'd actually second fix that socket with alive and neutral the wrong way around. And obviously it's not a massive deal for many appliances, but if the customer had plugged maybe their Hoover into it, well, that Hoover would have been blowing rather than sucking. And that would be a problem for me as well as for the customer. Because it's simple mistakes like that that will leave the customer thinking that you're a rubbish electrician, and that will stop them calling you for from the future, and they won't be recommending you to their friends and family. They'll be saying, I had this idiot round that made my Hoover blow. And you don't want to be one of these electricians that dread the customer phoning you up. You want to be confident that if that customer is phoning you up after you finish the job, they're probably phoning you up because they want more work done, not because there's a problem. You want to leave that job with full confidence that the work you've done was completed to a maximum high standard, what you're capable of. All the testing that electricians do is to make sure that that install that they've done is correct. Because how many times have you been to a customer's house where another electrician has done some work, only to find it was a simple fix? Maybe a loose cable, something that 10 minutes of testing they would have picked up on. The only reason that I like to return to a customer's house is to do more work. So carrying out these tests, they're going to save you time and money in the long run. I've been to a lot of jobs before where I've discovered faults on other circuits that I wasn't even working on, and reported them to the customer and asked if they'd want me to fix it. Obviously gave me more work with more money. Customers have watched me test before, and they appreciate that you're going so thorough through your own work. And that also gets them talking to their friends and recommends you and your business. So that makes you more work, more money. And you don't want to get that call saying, yeah, my lights are flickering, only to find that there's a loose connection in a switch. A continuity test would have shown that up. So testing would have saved that light flickering. So it would give you more time and more money. So it just goes to show that although testing is pretty boring, it's worth taking that little bit of extra time to do it. And for more ways to get more work or more money, check out the podcast, How These Simple, Easy Steps Will Fill Your Diary with High-Paying Customers All Year Round. It'll help your business grow even better. So until next time, I'll see you again. Half the expense, I tell you, of being an electrician is your test kit. Because these test kits are about £1, not this one anymore, it's probably cheaper. You've got your little Martindale, I've got 3 of these. And these are little cool things. So you don't have to take the lights to bits. You can plug your testing leads into these and they fit into all different sorts of lights. So this might be a good idea for you to stick in your test kit. All different sorts of fittings for lights that you can just grab onto the live earth, the neutral and live. But the one you use every day, let's be honest, you're going to plug this in, this is going to be every day. You're going to use this all the time. You can see because it's knackered. The numbers are nearly rubbing off.